This session, we will have an introduction for the sequence and series. First, we'll look about what is meant by a sequence and how the sequences and the series are formed from. A sequence can be defined as an ordered collection of things. Generally, we are using the numbers. Anyhow, it is mentioned as the defined as an ordered collection. Therefore, there is an order. If you are considering a sequence, consider a sequence, then there should be a defined order. And generally, we are using the numbers. Therefore, once you have a collection of number in you as an ordered array, then it can be considered as a sequence. Or else we can say that it is a set of numbers arranged one after another. But in some situation, instead of using the sequence, the word sequence, we referred it as the progression. But anyhow, you will have the this same meaning there. Therefore, if you are considering about a sequence, it is generally said that it is a collection of or a collection of the numbers or ordered things. Therefore, we can have them as in this way. Suppose that you are having the numbers as A1, then you may have next number A2, A3, A4. Likewise, you may have several elements, and here I will take an as the nth element. Therefore, these are known as the elements of the sequence, or in generally we are saying them as the terms of the sequence rather than saying them as the elements of the sequence. We tend to use them as the terms of the sequence. And the subscript is the set of positive integers 1 2 3 likewise, which indicates the position of the terms in the sequence. It is simply in this way. Here you can see that the subscripts, and these subscripts will be positive integers or simply positive whole numbers. It is 1 2 3. Likewise, you may have the values, and these 1 2 3 or these positive numbers or the positive values are therefore denoting of the position of the term. Here this a1, suppose that it is the first term, a2 suppose that this is the second term of the sequence, a3 it will be the third term of the sequence. Likewise, an stands for the nth term of the sequence. And when you are naming the nth term rather than naming it as a1, a2, an, we tend to use the term or the notation tn to denote the nth term. Therefore, to denote the nth term of any sequence, in term of any sequence, you can use the notation Tn. Therefore, we can use the notation Tn to denote the nth term of any sequence. Here, some examples related to sequences are included. Now you can see that the first sequence, it is 1 3 5 7. Say, simply we can say that it is the set of odd numbers. Then 2 4 6 8, it will be the sequence of even numbers 2 4 6 8. Here you can see that another sequence as 1 4 7 10, which is having the equal sequence which is having the equal distance between any two consecutive numbers. Therefore, this can be considered as an example for the sequence. And when we are discussing about the sequences, basically we are defining or we are categorizing the sequences as the finite sequences and the infinite sequences. If a sequence contains the finite number of terms, if a sequence has finite number of terms, then such sequence is said to be a finite sequence. But if a sequence having infinite number of terms, then such sequence is meant to be a infinite sequence. Therefore, If you are having a finite number of terms in a sequence, then such sequence is called as a finite sequence. Otherwise, in the sense, if a sequence has the having the infinite number of terms, such sequence is known as an infinite sequence. If it is an infinite sequence, it will never end. And here some examples related to the finite and infinite sequences are given below. Here you can see that it is the first sequence inside the curly brackets. The elements of the sequence has written down. Here we can see that it is 1, 3, 5, 7, and generally we are using 3 dots to denote the remaining elements. But these 3 dots says that it has infinitely many elements. Therefore, this type of series or this type of activity sequence, this type of sequence can be considered as an example for infinite sequence. It is because none of us will not be able to say what is the last term or the what is the ending term of the sequence. Therefore, it runs up to infinity. To denote it, we have using generally use the 3 dots to denote that it is not ending. It goes up to the infinity. In the second one also, it is given that it is actually a set of even numbers or the sequence of even numbers. Here also it is saying that it is from 2, 4, 6, 8. Likewise, it can be goes up to infinity. Therefore, these two can be considered as an examples for the infinite series. But if you see about the latter two sequences, here you can see that the third sequence is written as 1, 3, 5, and 7, and thereafter they are closing the curly brackets. Now you can see that there are finite number of elements in this sequence. There is only 4 elements. It means that it has a finite number of elements in the sequence. Therefore, this type of sequence is said to be a finite sequence. In here also, it is 2, 4, 6, 8. It is also a finite sequence. If I write it in this way, 2, 4, 6, 8, 10, and 12. Suppose that this is the sequence that I am considering. It is 2, 4, 6, 8, 10, and 12. Therefore, in here also we can see that there are finite number of elements in this sequence. Therefore, this type of sequence is also meant to be a finite sequence. And apart from this, the finite and infinite sequence, we are using some other notations in the sequences. We have previously discussed about the notation Tn. Tn is generally used to represent the nth term, and since it is the nth term, we are considering it as the general term of the sequence. Therefore, rather than saying it as the nth term, it would be better to name this Tn notation. This is the nth term we are having. Therefore, this would be considered as the general term. This would be considered as the general term of the progression or general term of the sequence. And when we are consider about this general term here, this subscript says that what is the position, and by combining the letter T and the subscript, it says that it is the value for the nth term. And if as an example, if you need to mention that it is the fifth term, then we just write it as T5. T5 in the sense it says that this is the fifth term of the sequence. Therefore, if you are considering about the rule for this 3, 5, 7, and 9, suppose that if the sequence is given as 3, 5, 7, and 9, then we can identify the common term, and it was identified that the common term as the Tn equals 2n plus 1. Once you do the substitution for the n, it is the position of the term Suppose that if you are taking the first term, then first term is taken by substituting n as 1, then it will taken as 2 times 1 plus 1, in the sense it is equal to 3. Now you can see that the first term is 3. Likewise, we can take it for the second term. Here we have identified that Tn equals 2n plus 1. Then the second term can be obtained by substituting n equals 2. Then this will be taken the value as 2 times 2 plus 1 itself equal to plus 5. Now you can see that second value is equal to plus 5. Therefore, if a sequence is given, then we can easily identify an common term for the sequence. And using this common term, we can simply calculate the value of the nth term. As an example, if the nth term is given as it is Tn equals 2n plus 1, and you may ask to find out the 10th term of this sequence. 10th term of this sequence, what you have to do is you have to do the substitution that the n equals 10. It is because you are going to identify the value of the 10th position. Therefore, what you have to do is you have to substitute the value for n equals 10. Then you will get this as T10 n equals 10. Then it is equal to 2 times 10 plus 1, in the sense you will get the value as 21. Therefore, here also you can see that it is the 10th term. Instead of using n, it is better to write it as T10. Therefore, this is how we are obtaining the nth term for a given sequence. Therefore, when you are going to obtain an nth term for the sequence, then first you have to identify what is the common term for the sequence. And here it is asked us to have an exercise related to this. Find out the first four term of the sequence, which is defined as the Tn. It is equal to minus 1 over n to the power n. We are asked to calculate the first four terms. Therefore, simply what we can do is, here we know that this Tn is equal to minus 1 over n to the power n. Therefore, to calculate the first four terms, what you have to do is you have to substitute the value for n equals 1, you have to substitute n equals 2, n equals 3, and n equals 4. Once you substitute n equals 1, then you will get T1. It is equal to minus 1 over 1 to the power 1 itself equals to minus 1. Then substituting n equals 2, you will get T2 on the second term. Then it is minus 1 over 2 to the power 2. Then you will get it as plus 1 4. Then n equals 3. N equals 3, then you will get the third term. Then it can be taken as minus 1 over 3 to the power 3, which equals to minus 1 over 26. Likewise, we can do it for the n equals 4 as well. N equals 4, in the sense we need to calculate T4. Here it is minus 1 over 4 to the power 4. Therefore, we'll get it as 1 over 64. Then you can write down the sequence as follows. Here, since it is just asked to calculate the first four terms of the sequence, here what we are going to do is I'm going to write down the terms accordingly. For the first one, it is minus 1, then it is 1/4, then it is minus 1 over 27, and the last one is minus, it is plus 1 over 64. Therefore, this is how we are using the common term to identify or obtain the nth term of a sequence. Now we will have a look regarding the how we are defining the series. A series is obtained from a sequence. fundamental or the foundation for series is actually a sequence. Therefore, once you add the terms of the sequence, then you will be able to obtain a series. Therefore, if you have the sequence as T1, T2, T3, Tn, these are supposed to be the first, second, third, and nth term respectively, then we can find out the series for this given sequence by adding the terms to each other. Therefore, you can simply get the series for these n number of terms as T1 plus T2 plus 3 T3 plus likewise Tn. If you are having more than that, then you can continue up to that, or else if you are having infinitely many, then you can continue it until the infinity as well. And when we are taking the summation of the terms, it can be denoted as or using the notation Sn. It is said to be the summation of n number of terms. It is denoted the summation of n number of terms, by it is by Sn, summation of n number of terms. Therefore, instead of writing it as T1, T2, T3, likewise, we can say that the Sn or the summation of n number of terms is equal to T1 plus T2 plus T3 up to Tn. Here simply we are getting the summation of the first n number of terms. This is how we are obtaining the series. It is if I brief about this, series is obtained by sequence. And simply what we have to do is we have to add the terms of a sequence to each other to obtain a series. When we are discussing about the sequence and series, basically we are having an idea or have a look regarding the arithmetic progression and the geometric progression as well. Therefore, first we will look about the arithmetic progression. If you are having a sequence in which the successive term maintain a constant difference is known as an arithmetic progression, and which is abbreviated as AP. Therefore, what you can see here is if you are considering set of numbers or set of elements of a sequence, then we can say that if you are having T1, here it is T2, it is T3. Likewise, we are having Tn here. Therefore, if you are considering the any successive term, here this T2 is the successive term to T1. Therefore, if you are consider this difference, this will be same for any two consecutive elements. Therefore, if you can see a constant difference between any two consecutive elements, then such a series is said to be an arithmetic progression. Therefore, here it says that we are having a common difference. It is means that the distance between two consecutive elements have the equal length. Therefore, if you are having the sequence having the elements as suppose that if you are having A, then next term is A plus D. It is because the second term is obtained by adding some value to the preceding term. Therefore, the successive term is obtained always by adding a constant term to the preceding term. Therefore, the third element can be taken as A plus 2 times D. It is because now what we have to do is A plus D, then you have to add another term. Likewise, what we can do is if you are considering it for the fourth term in the sense you will get it as the next highest term, it is the fourth term, it is now equal to A plus 3D. Likewise, what you can do is here you can see that if it is the first term, then you will get it as A times A plus 0 times D. It is for the first term. If it is second term, then A plus 1D. If it is third term, then you will get A plus 2D, and this is the third term. Then likewise this a plus 3D, stands for the fourth term. Therefore, now using the similar pattern, we can identify and or identify a general term for this set of we can say for the set of numbers. Therefore, we can simply say that the nth term of this or the general term of the arithmetic progression can be written as it is Tn. It can be taken as a plus. Here, if it is first term, then the value in front of the or the value multiplied by the difference is the value less than the term number. Here, if it is first term, then 1 less than 1. Then here it is used as 1 less than 2. Then here, since it is the third term, then common difference is multiplied by 1 less than the term number. Therefore, in this pattern, then we can say that the nth term or the general term as the it is a plus n minus 1 times t. Therefore, this is considered as the general term or the nth term of the arithmetic progression. It is given as a plus n minus 1 times d. And here it is considered that the a is supposed to be the first term of the sequence and d is supposed to be the common difference. D is the common difference of the sequence and a is the first term of the sequence. Therefore, this is what we have to keep in our mind, and what we have to be familiarized is now said to be the first term, and D is said to be the common difference, and N is the number of terms that we are having in the arithmetic progression. We consider about the first example related to the arithmetic progression. Here it says that if the fifth term of arithmetic progression, here it is abbreviated as AP, arithmetic progression, is 17 and its seventh term is 15, then we are asked to find the value of the 20 second term. It is should be 22nd term. Therefore, what we can do is first we need to write down what we know is the things that we know is we know that if it is given as an arithmetic progression, we know that the nth term of the arithmetic progression can be taken as it is Tn equals a plus n minus 1 times d. Now what we know is we know that the fifth term of the arithmetic progression is 17. Therefore, we know that it is the fifth term. It is now n equals 5. The fifth term of the arithmetic progression is 17. And then what we know, the next thing is, it is seventh term is 15. Seventh term is 15. It is T7. T7 is equal to 15, and we are asked to calculate what is the value of the T22. Now, using this common term or the nth term for the arithmetic progression, we'll try to build up some equations related to the first two values that they have provided for us. Here, the value is equal to n. The value of n is equal to 5. Then I will write down this as it is a plus 5 minus 1 times d equals to 17. It is because value is 17. Similar manner, we can say that a plus 7 minus 1 d is equal to 15. In this way, you can take that here it is a plus 4d is equal to 17. Here we can say that a plus 6d is equal to 50. Now we are asked to calculate the value of T22. To calculate T22, what we need is we can use the equation T22 is equals A plus N is equal to 22 minus 1 times D. Then we can take it as A plus 21D. But to calculate a value for this T22 or the 22nd term, we need the value of A as well as we need the value of D. Then what we can do is here we can see that these are two linear equations, linear simultaneous equations. Yeah, by solving these lead to linear simultaneous equation, we can simply obtain value for A and D separately. Then we'll take this as 2 minus 1. 2 minus 1, here you will get the value for the left hand side as 2D. Then 15 minus 17, it is minus 2. This leads to the value of D equals minus 1. Now we know that value of D is equal to minus 1. Then using one of these equations, again you can do substitution of D equals minus 1 and we can simply obtain value of A. Here I will take the first equation. If I consider the first equation, then we can do the substitution. It is A plus 4 times minus 1 is equal to 17. Then we can say that A minus 4 is equal to 17. Therefore, we can say A is equal to 21. Now we have find out what are the values of A and D respectively. Then by now using the appropriate substitution, you can obtain the value simply. The value of A is equal to 21 and then here it is 21 times minus 1. Then simply you can say it as 21 minus 21 since it is equal to 0. Therefore, you can say that the 22nd term of the given arithmetic progression is 0. Or else we can say that that is equal to T22 is equal to 0. Simply we can write the answer in this form. This is the first example we are taking, and in the second example it is asks us to calculate or find out this 20th term. Then what we can do is here it says that if 11 times the 11th term of arithmetic progression is equal to 9 times the ninth term, and we are asked to find out 20th term. Here it says that if you write down what it is saying, it says that 11 times the 11th term is equal to 9 times the ninth term, and then we are asked to calculate what is the value of the 20th term. Now using the common term for arithmetic progression, we can say that Tn is equal to A plus n minus 1 times D. Therefore, using the appropriate substitution here, we need to take T11. Therefore, value of n will be 11. Then once you perform the substitution, then and the calculation, then 11 times here you will get A plus n minus 1. It will become now 10. D is equal to 9 times then A plus A plus 80. Therefore, once you solve the brackets, then you will get it as 11 times A plus 110 times D is equal to 9 times A plus here it is 72 times D. In this way, you can take subject the value of A. Then if you take all the terms to the A terms to the left side, it is 2 times A. Then it will be equal to minus 38D. Dividing both sides by 2, you can take that value of A is equal to minus 90. We need to identify this value. It is because we are asked to calculate T20. To calculate T20, what we know is we know that N is equal to 20. By using this substitution, we can say that Tn is equal to a plus n minus 1 times d. Then we can say it is T20 is equal to a plus n minus 1. We are having it as 19. Then 19 times d, it is n minus 1, 20 minus 1, we'll get 19 times d. Now we need the value of a and d, but what we know is a is equal to minus 19 times d. Therefore, using that substitution, instead of a, we can use it as minus 19d, then plus 19d, then you will get the value of the 20th term as 0. Therefore, here we can get the value of the 20th term of this arithmetic progression as equal to 0. Then in the third example, it is given as the second, 31st, and the last term of the arithmetic progression are given as 7, 3, 3/4, then half, and minus 6 over minus 6 with 6.5 respectively. We are asked to find the first term and the number of terms for this exercise. Therefore, first we what we need to do is we need to find out the appropriate, or find out the numbers of these the terms associated with second, 31st, and the last. Thereafter, what we can do is we can simply solve these equations, and we can obtain the value for first term and the number of terms. Therefore, what we can do is we have given the second term. We have given the second term, it is T2, and we know that the T31, this 31st term is given. And then the next thing is they have given us the last term. Here we do not know what is the last term, therefore we'll keep it as just as Tn. Then according to the values that they have given, here it is equal to 7 and 3/4. Therefore, for the easiness of calculation, I will make it as improper fraction. Therefore, it is you will get this as 4 is 4 times 7, 28, plus 3 is just 31 divided by 4. Then 31st term is equal to half, and the last term still we do not know what is the value of n. It is what they are asked to find out, and here what we know is here it is equal to minus 6 and half. Therefore, if you make this as improper fraction, here you will get it as minus 13 over 2. Now what we can do is we are asked to calculate the first term. It is what we need to do. It is T1 simply we can say the first term. Okay, if I write the nth term like this here, we are writing the general term as Tn. It is equal to a plus n minus 1 times t. Therefore, this a is supposed to be the first term. We need to find out the value of a, and thereafter here we need to find out the value of n as well. Then using the first two equations, we'll try to obtain some equations. The second equation, using the second term, it is T2. Now we can write the T2, it is equal to a plus 2 minus 1 times d. A plus 2 minus 1 times d, you will get it as a plus d. It is equal to 31 over 4. Then using the 31st term, it is the T31. Then you will get here as a plus 30d is equal to half. Now you can see that there are two equations, first equation and second equation. If you subtract the first equation from the second equation, here you will get it as 29D in the left hand side. Then you will have to do this subtraction. It is half minus 31 over 4. If you perform this calculation, you will end up with uh, here you will get it as 29D for the left hand side. And if you taking the common denominator and once you do the calculation, you will get this as minus 29 uh, minus 29 divided by 4. Therefore, dividing both sides by 29, then you will get the value of D is equal to minus 1/4. Now you can see that the value of D is equal to 1/4. Then by substituting this value in the first or the second equation, you can take the value for A. If we are substituting it in the first equation, then we can say that value of A, we need to find out it. Then value of D is equal to minus 1/4. Then it is equal to 31 over 4. Then we can take that value of A is equal to, if we take 31 over 4 and here we are taking this to the right hand side, then it will become plus 1/4. Then you will get it as 32 over 4 itself equals to 8. Now we have obtained one answer. We know that the first term is equal to 8. This is one answer that they asked us to find out. For the first part, they are asking us to calculate the first term of this sequence, and then we are asked to find out number of terms. It is because they have given us the last term as well. Now what we can do is, now we know the value of A and D, then using this equation, now what we can do is, you can write down the common term or the common format for this equation to write down the nth term. Here it is given as Tn. Tn is equal to, we have identified that it is equal to minus 13 over 2. Minus 13 over 2. Now if you write down the format of the common term, you can take this Tn is equal to A plus n minus 1 times D. It is equal to minus 13 divided by 2. But what we need to do is, we need to calculate what is the value of n. Now we have identified that using the previous calculation, we have identified that A is equal to 8 and we have found that D is equal to minus 1/4. This is what we have identified. D is equal to minus 1/4 and A is equal to 8. Therefore, by substituting these values in this equation, then you can take that value of A is equal to 8, then n minus 1, D is equal to minus 1/4 is equal to minus 13 divided by 2. Then by taking this A to the right hand side, then you will get it as n minus 1 times minus 1/4. Then here you will get it as minus 13 over 2 minus 8. Here you once you perform the calculation, you will get it as minus 40 minus 4 1 over 4. And here you will get it as minus 29 minus 29 over 2. And then what we can do is, here we can do the calculation just by multiplying this Here you will have this as, if you are isolating in -1, it means that you have to multiply both sides by -4. Once you perform the calculation, then here you will get it as minus is it will be equal to plus 58 once you perform this calculation. Then you will get using this equation, you will be able to get n equals 59. Therefore, here we can see that there are 59 terms in this arithmetic progression. It is because the last term that they have given for us as minus 13 over 2. Therefore, it will be equal to 59th term of this arithmetic progression. Therefore, using the set of equations that we have considered, we can obtain the first term, common difference, and the number of terms in the arithmetic progression as well. And thereafter we will discuss about the series of an arithmetic progression. First we have defined that if you are having the numbers as, suppose that if you are having the numbers as a1, a2, a3, or this t1, t2, t3, the terms, we had the terms as t1, t2, t3, likewise up to tn. We said this type of arrangement as a sequence, but once you convert it by or just using the addition or the summation of the terms, t1 plus, t2 plus, t3 plus, likewise tn, this has converted our sequence into a series. Therefore, here we have already identified an arithmetic progression. Here it is just a sequence only. The first term was a, then next term was a plus d, third term was a plus 2d. Likewise, you are having a plus 3d. Likewise, the nth term was a plus n minus 1 times d. Then you can see that it is if you are taking the summation of those terms, then you can create a series of an arithmetic progression. Therefore, the series of an arithmetic progression can be obtained as in this form. Here we can simply take here we can take it as a first term, second term is a plus d, then it is added to the third term, then it is added to the fourth term. Likewise, you can have the addition of the terms to or the addition of the terms of the sequence to construct the series. Therefore, what we can do is, once you have the addition of the terms, then it can easily or simply create the summation. If you are taking n number of terms, the addition of n number of terms, then you can denote it as the SA. It will be summation of n number of terms. Then we can say that Sn is equal to a plus d. It is the second term. If you are considering this is the first term we are having, this will be second term, then third term, fourth term. Likewise, you may have the nth term here. Therefore, this gives us the summation of first n number of terms. Now we are going to obtain an equation for obtaining the summation of n number of terms of the first n number of terms of an arithmetic progression. Then what we can do is here this is the proof. What we are writing, what we are doing here is we are just writing the terms in the reverse process. Therefore, n term come first, then n minus 1 term, n minus 2 term. Likewise, this was the first term that we are having. Then we are adding these terms with each other. Here you can see that the first term added to here, if you are writing it in the reverse way, then you will get it as a plus n minus 1d. This was the last term. Here in the second equation, what we have done was just written this the summation in the reverse order. Last term came first and first term came last. Likewise, now we are adding the terms as in their order. Then this is the second term we are having. Then it is added to this term. Likewise, the next term, here we are having the next term, it is added to this term. Likewise, we can have it for the last term as well. Here it is added to the term A. Then by adding or having this summation, what we can obtain is we can take this as, here we are having one Sn and another Sn. Therefore, the left hand side as the summation, we'll get it as 2 times Sn. Then summation of the first term with first. Here it is a plus n minus 1 times d. Here you will get 2a. Here it is simply a plus n minus 1 times d. Here you will get it as 2a n minus 1. Then you have to do the summation. It is the next one is a plus d is added to a plus n minus 2d. If you do this calculation, then again you will get this as equal to, the summation of this quantity will be again equal to 2a plus n minus 1 times d. Likewise, if you do the summations, then here you will get here as 2a plus n minus 1 times d as the last term. If you count the number of terms in the summation, here you may identify that there are n number of terms. There are n number of terms. Therefore, what we can do is, now we can say that we have repeated the same term for n number of times. Therefore, what we can do is we can simply say it is equal to n times 2a plus n minus 1 times d. It is n times 2a plus n minus 1 times d. Likewise, we can obtain an answer for the summation of n number of terms as Sn equals n divided by 2 times a plus n minus 1 times d. And also we can make some alteration for this calculation as well. Now you can say that this is equal to Sn is equal to n over 2. Here instead of taking this 2a, I will take it as a plus, this 2a is separated now, a plus n minus 1 times d. Now what we can do is we can simply consider this as a single term. This is one term. Actually, this is the first term we are taking, and here this is the nth term we are having. Therefore, we can simply say that this is equal to the summation of first n number of terms is equal to n over 2 times a plus. If you are considering this as L, this is the last term, then it will be equals to a plus, and therefore this is another equation. If you know the first and last term with the number of terms, then you can take the summation using this equation. But if you just know the first term, the number of terms, and the common difference, then you can use the first equation to obtain the summation. Now we'll discuss an example related to obtaining the series of arithmetic progression in simply. Here it is given as we are asked to find the summation of the first 19 terms. We are asked to calculate the summation of first 19 terms, and it is given that a4 plus a8 plus a12 plus a16 is equal to 224. This is the question that they have given for us, and we need to find out a suitable answer for this summation. Okay, now if you write down the next example, We are asked to calculate the summation of first 19 terms. This is what we need to calculate, and they have given us the data or the information as the fourth term plus eighth term plus 12th term plus 16th term is equal to 224. This is what we know according to the information that they have given for us. A4, A8, A12, A16. The summation of these four terms is equal to 224. Therefore, what we can do is we are asked to calculate S19. To calculate S19, what we can do is we can use the equation S19 is equal to, here it is 9. If we are having Sn, here what we can do is n divided by 2 times 2a plus n minus 1 times d. Then instead of n, now you are having 19, therefore we'll get it as 19 over 2. Then here we are having 2a plus 19 minus 1, it is 18 times d. Therefore